So here's an interesting set that's just come today and has been given to us very kindly as a gift from a viewer. And it is an Amstrad 901, and it's the made in Japan version, so it's the real one. And it seems to have got a case problem. I think it's had termites which have eaten the case away. So it's supposed to work according to the note. So let's give it a service. And it's the one which uses the obsolete power lead, but it's come with a plug, so that's brilliant. Otherwise we'd have had to swap it for the square round type. Just check the fuse. That's 2 amps, that should be alright. Well, we'll get it connected to our crocodile clips. Well, somebody once paid £90 for that. We'll get our standard Cybernet mic because it's a Cybernet 002F. No fakery on this one, it's the real McCoy. Power supply on 13.8 volts. Radio arms, come on channel 23. Get that on 20. Pop the squelch up a bit. RF going to full. And we've got a new fluorescent tube in our bench light. It's not the colour temperature I would normally opt for, but it was cheap. I think £1.99 was a good deal. It's got the wing nuts, which these originally came with, so I'll put those to one side, try not to lose them. I'll go and get a piece of paper to write down all the parameters. Playing for a funeral today of somebody who was just 61 when he was run over on his mobility scooter, so not good when it's somebody my kind of age. Church was packed, 90-minute funeral. So it's the 11th, I think, today. It is 11th of September 24. Amstrad CB901, and let's look at the serial number. I'm sure I'll find somebody in the trade who's got a bit of a case for me. Right. So we'll put picture-in-picture on, and let's see what it's doing. So I'll just put some more test equipment on as well. Need to plug the test equipment in. Put the aerial in instead of the test gear. Yeah, it's 3.1 watts. So my usual rule with these, if they do 3.6 or above when we've tuned it, then that's fine. If they won't do 3.6, then we'll change the ballast resistor. Old-fashioned name for dropper resistor. Used to be a Beretta, didn't it, in the 1930s? There's people who remember electronics in the 1930s. 3 watts channel 40. Oh, 3.1. What am I doing? I'm telling you 3.6 and then writing it down. Right, low power not adjustable on these. It is currently doing 300 milliwatts. No, it's not, it's 290 milliwatts, not going to be generous. And then current consumption 1.182 is about where they end up being. Deviation on this test set, wow, it says 2.5. So if it's true, that's fine. And if it's not true, we'll adjust it. We will do the VCO. I've only just put the test gear on 10 minutes ago. Hit the frequency with a pinch of salt. Just get that camera on. That one. 27. Oh, we're still on channel 1. 27. 79073. So it's not noticeably out, but it certainly needs pulling up. Right, we'll set the signal generator to the same frequency as what it's transmitting on, so that it's a fair test. There we go. Right, let's have a look at what the SINAD meter's got to say. Mice haven't moved it back, have they? Alright, doesn't sound like we're plugged in. That's because we're not. So I'll put extension speaker in there and the PA speaker in there. Making sure RF gain's at full. Zero 0.35. Zero 0.26. And for 20, oh, not quite at 1. It's 1.2. Full squelch is 100 microvolts, which is where we want it. And the sensitivity squelch on the radio is 0.3. Okay, so the meter 100 microvolts for a CB in the UK should be there, which it is, and on transmit we should be lighting 4 bars. We're lighting 5, so doesn't have a meter lamp. PA. Testing 1 2, testing 1 2. That's working. Let's put my walkie-talkie on. See if the Roger bleep's working. It is. There we go, everything's working there. Right. We'll get it opened up. Oh, security sealed. bit of corrosion after 40 years. So it's got the 3 watt ballast resistor in, which is the factory fitted better one. So, radio back on, channel 1 selected. And I'm just going to need the Amstrad instructions, so I have them here. I say Amstrad, it's Cybernet 009F. It is 2 volts, channel 1. Let's get that connected. Needs to be to chassis. Use one of the coils. Far side of capacitor 9 is there, and we should have 2 volts. We've got 2.3. That's near enough, but it's a demonstration, so we'll adjust that coil until we get 2. You've got to take some of this off this setup with a pinch of salt, because it never says what the manual says on the channel 41. I just don't know what meter they were using. That's probably the biggest thing. Lots of service manuals will say, for example, with an AVO8 or with a digital voltmeter or whatever, but it doesn't. Channel 40 is supposed to be 4 to 5 volts. Well, that's fine at 3.6, I can assure you. Right, on transmit we're supposed to have 2 volts as well, so it's a bit low, so we need to adjust the trimmer. So we've got 2 volts now on transmit. We've still got 2 volts on receive. 2 volts on transmit. Let's go to channel 40, 3.6 on receive, 3.5 on transmit. That's fine. So that's the VCO set. So it's now 2 volt plus 2 volt. I can't remember what it was before, but it doesn't matter. Memory like a sieve. Right, let's go through the transmitter. I mean, it doesn't look messed with at all, but I won't be surprised if deviation isn't somewhere silly. But we'll find out. Right, I'll put the crocodile clip lead back. Put the meter away. That's one thing actually done. So there's transmitter line up. Let's go over to the main meter. So we're beyond the 3 watt scale, so we'll go into the 30 watt scale. So we're now looking around here for 4 watts. I've said before, it's not just peak, it's centre of the peak. Oh, I'm on the wrong channel. I'm glad I just double checked. Turn the volume down. Try again. So whisker away. I'll just see whether we've got the placement problems with the coils, because that can sometimes happen. Just check these two again. So it's now hot, it's 3.9 watts. Channel 1, .95, channel 40, 3.9. Good. So we don't need to change the ballast resistor and thus incur that expense. Now, where's low power gone? Has it got worse or better? It's anybody's game with this. It's now 350 milliwatts, so it's actually improved slightly. It sometimes goes the other way. So it's not quite 400 it ought to be, but there you go. Put the switch back in if I can actually manage that. So it's not often you get the one with the better ballast resistor. Trouble is, it's his 3 watt component, so obviously it starts heating up, and then the set is going to start losing a bit of power. But we normally fit 6 watt capable ones in rather than the 3 watt capable ones. Anyway, that's absolutely fine. It survived 40 years doing 3.1 watts. Now it's doing 3.95 or 3.9. Right, let's go into the meter set. So I want that to read 4. Remember, it's relative to SWR, so when we put it on an aerial, it may read 1, it may bang across, but the radio will still be doing the power it's doing. So don't be fooled by a meter and I'm only doing 1 watt. Well, you're probably not. So I'll do deviation next, then we'll come back to frequency. Just give the test set a little bit more to warm up. So I'm going to plug into the test set behind me. I don't trust the deviation meter on this one, owing to dodgy capacitors in it. Right, so plugged into the test set behind me. Wow, is it a bit high? Yeah, it's 3.2. Just pop that down a bit. Wow. That's 3.2. Down to 2.5p. Right. It's so close to 4 watts when it's cold, you know. Let's see what the deviation says on this test set. Wow, he says about 2.2, so there you go. 2.2 to 2.5. 3.5. It was about 3.2. So that needs to come down, or end up breaking up on sets with decent filtering. See if we can do anything about the frequency. So let's see what we've got currently. Let's go over to that. 2779075. So we'll bring it up. I will check it right at the end. I think that's probably as far as it's going to go without changing the reference crystal. The right tool, but I need something that's a bit sharper. $27,080. I can't let it out like that. So we'll see what happens when it warms up in a bit, otherwise we're going to have to change the reference crystal. I'm trying to get a new one that works cheaply is another thing, isn't it? Right, so we'll move on to the receive. I'll reset the signal generator for 2779080, so we're doing a fair test. There we go. Let's put the oscilloscope on. Check the detector, which is lurking here somewhere. It's that one. Miles out, absolutely miles out. Wow. Don't often see one that bad. That was either receiving quiet or receiving garbled, but it certainly wasn't right. Over to the SINAD meter. Compensate for the mice. Where's it gone? Yeah, it'll do nicely. Start with the front end. Drop the signal to about there, 6, and see whether we can improve it. Tiny bit there. I need to drop this 12. Go back to that first one. Right, we'll put a bit more signal on to do the IFs. There we go. Let's get a new reading. No, that's not actually very good. I'm going to go through this again. Start with the detector. It's 0.6, which these usually do better. Do the detector again. checking I've not knocked the RF gain. IFs. I'm going to untune them. I'm going to do something which is just out of interest. Reset the detector again. So for 12 dB, we've got 0.7. This isn't out of spec, but it's only just in spec because the manufacturer says 0.7. I've been used to so many around about 0.3 at the moment that what's that? 0.58. For 20, it's just under 1.3. So you can see that these figures are worse than before I started, but that's because the detector's now right. So it doesn't now sound garbled or quiet. So this is the balance. Right, let's see where S9 is for the S meter. It's there. Now the squelch will have to be reset. So squelch to full. No, it's exactly the same still. So see what the minimum sensitivity of the squelch is. 0.3, the same. Well, now usually when the detector's out, the squelch is really effective, but on this occasion not. Right, so it's a very average performer as far as receive goes. Transmit's good, and we need to do something about it being off frequency. It's not noticeably off frequency. I've no legal requirement to make it any more spot on, but I would like it better than that. So we will see if we can find a crystal that actually is going to work. So I'll unpower it, unsolder the crystal, but I can't say the last time I saw a detector so far out on the radio. I'll pause the video while I find a crystal that works. Right, so the good news is I've found one, but does it work? That's what I've taken out, and what I've put in is out of this scrap Mustang 3000 that we bought off a radio rally. Still in there, so good. Does it work? Moment of truth. Yes, it does. We're going to have to come back to this later before doing an on-the-air test, because it's now been heated up, so it's going to be different. Yeah, I can't get that on frequency because it's now too high, so we're going to have to come back. But I think I've done everything else, but I can't even put it on the air with it being that high. Okay, second time lucky. That first one wouldn't come down far enough, so let's see what we've got with this one. Again, it's going to have to cool down, but we can see where it's... Yeah, that's going to be great. Okay, I'll check it again, of course, before we do anything serious with this set. Check again. Right, well, we'll put the lid on it. Well, the lid we've got. I'll have a word first of all with my trade contact in Sheffield. And then we'll have a word with my trade contact in Skegness. Yep. Test gear off. And we'll start off like we did with the aerial. Got lightning outside. Take that off. 190 Roger. And I just need to do something about that knob, don't I? I've got a knob missing, the tone one. I'll leave it in the higher position. $19, Roger. No. Right, so we're doing on the air test with it like that. I will put... We had half a case, didn't we? What I don't want to happen, it's well away from the innards. Tell you what, we'll keep it monitoring 19. it's so stormy out there, they've probably hidden their radios. It does offer some protection rather than just having bare board. I remember to put these wing nuts back. So it's always nice to have the real Japanese one. Imagine somebody stealing this radio and the police say, how can you recognise it? Well, you say, because half the case is missing. Let's flick round again. Nice, Roger. Right, we'll see how that works on a scratchy corner test. So, genuine Amstrad 901, thanks for sending that in to the viewer who's done that, and it's another one that will carry on to live the tale, and we will get that case sorted.